What if the strongest storm ever recorded on this planet hasn't happened yet? What if it's still ahead of us, quietly gathering strength somewhere over warm, dark water right now, while most of us are simply going about our day? Before we go any further, do one small thing for me. Hit like right now, not because I'm asking nicely, but because this video only reaches the people who actually need to see it. If enough of you tap that button in the first few seconds. Subscribe if you want to know the moment the next monster storm starts forming, before it becomes headline news. And send this to one person who lives near water. Not because it's polite, because it might genuinely matter to them one day. Okay, let's get into it. To understand why scientists are watching the oceans with real concern, you first need to understand what actually makes a storm the strongest on Earth. It's not just wind. Wind is the headline number, the thing that gets repeated in every news clip. But it's only one piece of a much bigger and much more complicated machine. A storm like this starts small, almost embarrassingly small. A cluster of thunderstorms drifting over warm ocean water. Disorganized, shapeless, easy to ignore. Most of these clusters fall apart within a day or two. They run into dry air, or wind shear rips them sideways before they can build a proper structure, or the water beneath them simply isn't warm enough to keep feeding them. They dissolve back into ordinary weather and nobody ever hears about them. But every so often, the ocean gives one of these clusters everything it needs to become something else entirely. Warm water, not just at the surface, but deep down, so the storm can't cool itself out by churning up colder layers underneath it. Calm air above it, so nothing shears the storm apart before it has a chance to organize. And an efficient exhaust system high in the atmosphere, letting the storm vent all that rising, saturated air upward and outward instead of choking on itself. When all three of those conditions line up at once, something happens that meteorologists have a very specific, very unsettling name for. Rapid intensification. It's not a vague or dramatic term invented for television. It has an exact technical definition, an increase in maximum sustained winds of at least 35 miles per hour within a single 24-hour period. Storms that hit this threshold are not gradually building. They are exploding. Picture a storm that was barely a tropical depression on Monday. Disorganized. Weak. Nothing anyone was worried about yet. By Wednesday, it's a monster with sustained winds over 150 miles per hour, a tight, well-defined eye, and a wall of destruction wrapped around its center. That is not science fiction. That is a documented repeating pattern, happening more and more often across the world's oceans, and it's exactly the kind of storm scientists mean when they talk about the strongest storms on Earth. Here's the part that should make you sit up straight. A tropical cyclone, whether we call it a hurricane, a typhoon, or a cyclone, depending on where in the world it forms, is essentially a heat engine. It pulls warm, moist air off the ocean's surface, drags it upward into towering columns of thunderstorms, and releases the stored heat as that moisture condenses into rain. The warmer the ocean, the more fuel is available. The more fuel available, the higher the ceiling of possible intensity becomes. This is not opinion. This is basic thermodynamics. The same physics that powers a car engine or a steam turbine, just scaled up to the size of a small country. And right now, large stretches of ocean across the tropics are sitting well above their historical average temperatures, not by a fraction of a degree that only a scientist would notice on a graph, by margins wide enough to completely change how storms behave once they start to form. Let's put some real numbers around this so it doesn't stay abstract. A storm officially becomes a hurricane or typhoon once its sustained winds cross 74 miles per hour. Category 5? The highest and most catastrophic classification on the scale begins at 157 miles per hour. The strongest storms ever recorded have pushed past 190 miles per hour, with gusts even higher and central pressures so low they read almost like typographical errors to anyone unfamiliar with meteorology. Pressure, by the way, is one of the best hidden indicators of true strength, even though it rarely makes headlines the way wind speed does. The lower the pressure at a storm's center, the more violently air is being pulled inward and upward, and the more powerful the entire system becomes. The most extreme storms ever recorded have central pressures low enough that meteorologists still use them as a benchmark, a kind of grim measuring stick against which every new powerful storm gets compared. When a modern system starts approaching those historic numbers, that's the moment scientific caution quietly turns into genuine alarm inside forecasting offices. Satellite imagery shows the telltale signs that experienced meteorologists dread. A tightening, symmetrical eye. Cloud tops so cold and so uniform they look almost artificial from space. A structure so textbook that forecasters don't need a second opinion to know exactly what they're looking at. When that structure appears over open, warm water, with days of ocean still ahead of it before any coastline, the alarm bells start ringing quietly behind the scenes, long before the public ever hears about it. Here's an uncomfortable truth scientists keep repeating, even when it isn't the answer people want to hear. The total number of tropical storms forming each year hasn't dramatically changed across the decades of reliable record keeping. What has changed, consistently, is the proportion of storms that reach the very top of the intensity scale. More of the storms that do form are becoming major storms. More major storms are becoming historic ones, and they are doing it faster than they used to, which means less warning time for the people standing in their eventual path. Think about what that actually means for a coastal community trying to plan its next move. If a storm takes 5 slow days to build toward its peak strength, emergency planners get 5 days of steadily rising urgency to work with. 5 days to convince people to evacuate, open shelters, and secure critical infrastructure. But if a storm can leap from a weak tropical system to a catastrophic monster in under 48 hours, while still hundreds of miles from land, that entire safety margin collapses almost overnight. People wake up to a forecast that has completely changed while they slept, and there is far less time to convince a skeptical population that this one is different, that this one deserves to be taken more seriously than the last 10 storms that fizzled out. This is the central tension driving nearly every serious conversation among meteorologists right now. It isn't only about how strong storms can theoretically get, it's about how little warning we may actually have before one arrives at that strength. And when a storm like this is tracking toward islands or coastlines still recovering from a previous disaster, the stakes climb even higher because the target isn't a blank slate. It's a community already running on damaged infrastructure and thin reserves, because here is something people outside these regions rarely stop to consider. Recovery from a major storm doesn't happen in days or weeks. It happens over months, sometimes years. Roads, ports, power grids, water treatment plants, hospitals, cell towers, all of it has to be repaired or completely rebuilt. And for small island communities sitting in the middle of an ocean, every replacement part, every generator, every construction crew has to be shipped or flown in across enormous distances at enormous cost. If a second major storm arrives before that recovery is finished, it isn't hitting a healthy community starting from zero. It's hitting one that is already standing on crutches, with its defenses down and its reserves depleted. That is the nightmare scenario climate scientists quietly worry about with increasing frequency in their research. Not a single catastrophic storm, but back-to-back catastrophic storms hitting the same vulnerable places before they've had any real chance to heal in between. And in a warming ocean environment, that scenario is becoming less rare with each passing decade, not more. All right, quick pause here. If this is the kind of information you want delivered the moment it changes, not buried 3 days deep in a news cycle after everyone's already moved on, subscribe now and turn notifications on. I'm not going to beg for it. I'm simply going to tell you plainly. The next update could matter to someone you personally know. Make sure you don't miss it. Now let's keep going, because the science actually gets more fascinating from here. Let's talk about how meteorologists actually watch something like this develop, because the process is far more sophisticated and honestly, far more tense behind the scenes than most people realize. It starts with satellites parked in geostationary orbit, constantly imaging the same patch of ocean every few minutes, tracking cloud temperatures, wind patterns, and moisture levels with astonishing precision. Now, when something starts to organize into a real threat, specialized aircraft, essentially flying laboratories, are sent directly into the storm to measure wind speed, pressure, and internal structure from the inside out. Yes, human crews fly airplanes into these storms on purpose, releasing instruments called dropsondes that transmit live data all the way down to the ocean surface as they fall. All of that raw data feeds into massive computer models, essentially giant simulations of the entire atmosphere run on some of the most powerful supercomputers on the planet. And here's something that might genuinely surprise you. Even with all of that technology, the models often disagree with each other quite significantly. One major forecasting model might predict a storm curving toward one stretch of coastline, while another respected model shows it landing somewhere else entirely, sometimes 50 or 100 miles apart, days out from landfall. That gap between competing models is exactly why meteorologists sound cautious even when they sound urgent on camera. They are not hiding uncertainty from the public. They are being honest about it, because pretending to know an exact path when the atmosphere itself hasn't fully decided yet would be reckless and irresponsible. This uncertainty creates real anxiety for emergency planners on the ground, the people whose decisions actually save or cost lives. Imagine being responsible for deciding where to send evacuation orders, knowing the storm's center could land in one of 2 very different places, each scenario meaning a completely different set of communities absorbing the worst of the impact. That is the impossible math emergency managers wrestle with every single time a major storm approaches, and it's part of why early decisive action matters so much, even before the exact bullseye has been confirmed. Now, let's talk about what actually kills people in storms like this, because it's rarely what most people instinctively assume. Wind speed gets all the headlines, but historically, the majority of deaths in major tropical storms come from water, not wind. Specifically, storm surge, the wall of ocean water physically pushed on shore by a storm's own circulation. A powerful storm approaching a low-lying coastline can push surge levels of 15, 20, even 25 feet above normal sea level. That isn't a large wave crashing on a beach. That is the ocean itself, rising and moving inland as a solid mass. And in many cases, it is simply not survivable for anyone caught in a typical structure directly in its path. Then there's rainfall, which deserves just as much respect as wind and surge combined. A storm doesn't need to make direct landfall to cause devastating flooding hundreds of miles away. Even a storm that stays offshore can dump an extraordinary amount of rain onto a region in a matter of hours. Overwhelming rivers, drainage systems, and hillsides that were never built to handle that volume of water so quickly. Mountainous terrain makes this dramatically worse, because storms are physically forced upward over elevated land, wringing out even more moisture as they climb, a process meteorologists call orographic enhancement. This is why mountainous islands and coastal mountain ranges often suffer landslides and catastrophic flash flooding long after the wind itself has died down and the skies have cleared. So when scientists warn about the strongest storm on Earth, they are never just talking about wind records on a chart. They're talking about a combined, layered threat: wind, surge, and rainfall arriving together, sometimes over a period of many hours, sometimes over multiple days if the storm decides to slow down. And speed of movement matters more than most people think. A fast-moving storm passes through quickly, brutal but brief, like a punch that lands and moves on. A slow-moving storm parks itself over a region and batters it for hour after hour after hour, multiplying the total damage, even if its peak wind speed is technically lower than a faster storm somewhere else in history. Some of the most devastating flooding disasters ever recorded came not from the strongest storms by wind speed, but from storms that simply refused to move, sitting over the same unlucky patch of ground for days at a time. Here's something that might genuinely change how you think about all of this. Despite everything working against them, some communities facing storms with wind speeds over 150 miles per hour have come through with remarkably few, sometimes zero, confirmed deaths. Not because the storm was somehow gentler than forecast, because the warnings went out early, because people took them seriously, because shelters opened before conditions turned dangerous, and because officials communicated clearly and urgently instead of vaguely. That kind of outcome is never luck. It is the direct result of preparation meeting discipline. Officials in storm-prone regions have learned, often through painful past experience, that the moment to act is when forecasters start using words like extremely dangerous or life-threatening, not when the wind actually starts howling outside the window. By the time you can hear the storm arriving, the safe window for relocating has usually already closed. This is genuinely one of the most hopeful parts of modern storm science. We cannot yet stop a storm from becoming the strongest on Earth. But we have gotten remarkably good at predicting when one is coming, and communities that take that information seriously are proving again and again that survival is possible, even against historic, record-breaking intensity. All right, let's do this next check-in a little differently. I'm not going to ask you to like or subscribe this time. Instead, I want you to do something a bit more useful. Drop a comment right now naming a coastal region you personally care about, somewhere you've lived, somewhere you've visited, somewhere family still calls home. I genuinely want to see how far this reaches. And if you're already subscribed, just know that the next video goes out the moment new information comes in, no delay, no filler. Okay, let's push forward properly. Let's step back now and ask the bigger question hanging quietly over everything we've covered so far. Is this actually getting worse, or does it just feel that way because of how fast news travels today? Scientists are careful people. They generally dislike dramatic language, and they especially dislike connecting any single storm directly to a broader trend, because weather is inherently chaotic, and any one event can always be an outlier. But when you zoom out and look at decades of data instead of a single storm, a consistent pattern does emerge, and it's one that climate researchers have been flagging with increasing urgency in their published work. Ocean heat content, essentially how much stored thermal energy exists in the upper layers of the world's oceans, has been trending upward for decades. This isn't a controversial or contested measurement sitting in some obscure corner of science. It's tracked continuously by satellites, floating ocean buoys, and research vessels across every major ocean basin on Earth. And the trend line points consistently in one direction: warmer water at the surface, warmer water beneath the surface, more stored energy available to fuel a storm the moment conditions allow one to form and organize. The result isn't necessarily more storms overall in any given year. The data on total storm counts across the decades is actually fairly stable and doesn't show a dramatic upward slope. What is clearly shifting is the ceiling. More of the storms that do form are reaching Category 4 and Category 5 intensity. More of them are achieving that intensity faster than historical patterns would have predicted just a generation ago. And in some cases, storms are maintaining major intensity closer to landfall than they used to, robbing coastal communities of the natural weakening that often occurred in past decades as storms approached shallower coastal waters. This matters enormously for something called warning lead time, which is really just a technical way of describing how much notice people get before disaster physically arrives at their door. A slow-building storm gives forecasters days of escalating certainty to work with and communicate clearly. A rapidly intensifying storm compresses that timeline dramatically, sometimes to less than 48 hours between initial concern and catastrophic landfall. And that compression is exactly why meteorologists keep emphasizing preparation before a storm even fully forms, rather than waiting for absolute certainty about its final path and peak strength. There's another layer to this that doesn't get discussed nearly enough in mainstream coverage. Some of the regions most exposed to the world's strongest storms are also some of the most vulnerable in terms of infrastructure and financial resources. Small island nations, remote coastal communities, and rapidly growing coastal cities in developing regions often lack the deep reserves, redundant infrastructure, and rebuilding capacity that wealthier regions can draw on. When a historic storm hits a place like this, the damage isn't measured only in dollars on an insurance report. It's measured in months or years of lost stability, delayed recovery, and communities left more exposed to the next storm before they've finished recovering from the last one. This is the compounding disaster scenario scientists worry about most in their long-term projections. Not one catastrophic storm in isolation, but a repeating pattern of increasingly powerful storms arriving faster. Then fragile regions can rebuild between them. It's the difference between an isolated tragedy that a community can eventually recover from and a slow-motion crisis that keeps repeating in the same vulnerable places, year after year, without ever fully resolving. So what should you actually take away from all of this, especially if you don't personally live anywhere near an ocean? First, understand that the phrase strongest storm on Earth is not empty clickbait anymore. It describes a genuine, trackable, scientifically documented category of event, and the frequency of storms qualifying for that description has measurably increased in recent decades according to long-term records. Second, understand that warning systems, while never perfect, have become remarkably good, and the biggest remaining variable in whether people survive these storms isn't the forecasting technology itself. It's whether people actually act on the warnings quickly enough once they're issued. Third, and this might be the single most important point in this entire video, preparation is not paranoia. Every single time a region has come through a historically powerful storm with minimal loss of life, the story behind that outcome tends to be the same. Early warnings issued with confidence, clear, honest communication from officials, evacuation carried out before conditions became dangerous rather than after, and a population willing to take an unprecedented forecast seriously rather than assuming the next storm would behave exactly like every ordinary storm that came before it. This point matters enough that I want to say it one more time before we move forward. Follow this channel, not for entertainment value, but as an actual early warning resource for yourself or anyone you care about who lives near a coastline. Turn notifications on. If a storm like this ever forms near where you live, the extra hours of warning you get from paying attention here could genuinely be the difference between calm, organized preparation and last-minute panic. That is not a sales pitch. That is simply true. Now let's talk about what typically happens after a storm like this makes its first landfall, because the story rarely ends the moment the eye finally passes over. Storms of this intensity almost always continue moving afterward, often maintaining significant strength as they cross open water toward their next potential target. Forecasters continue tracking these systems for days afterward, watching closely whether they'll encounter cooler water, increased wind shear, or enough land interaction to gradually weaken them, or whether they'll find another patch of warm ocean and reignite their intensity all over again with frightening speed. This is part of why serious storm coverage never stops at the first landfall. A system that devastates one region can still carry more than enough energy to threaten a second location, sometimes even a third, days later, arriving with reduced but still genuinely dangerous intensity. Coastal cities positioned downstream of a storm's projected path have to begin their own preparations well before the storm physically arrives at their doorstep, using the data gathered from its first landfall to refine exactly what they should expect when their turn comes. And this is where the global nature of this threat becomes impossible to ignore. A storm that begins as a disorganized cluster of thunderstorms in the middle of an ocean can, within a single week, threaten multiple countries, multiple economies, and millions of people spread across a vast stretch of geography. This is not a small regional weather story confined to one news cycle. It's a genuinely planetary one, and the ocean basins capable of generating the strongest storms on Earth also happen to border some of the most densely populated coastlines in the entire world. Let's bring this back now to something deeply human, because it's easy to get lost in wind speeds and pressure readings and forget that every one of these numbers represents real people making impossible decisions In real time, often with very little notice, somewhere, right now, a parent is deciding whether to leave their home with nothing but a bag of essentials, trusting a forecast about a storm they cannot yet see or feel outside their window. Somewhere, an elderly resident is weighing whether the walk to a shelter is worth the effort, based entirely on how seriously they personally take a warning broadcast on the radio. Somewhere, an emergency official is staring at two different computer models, predicting two different paths for the exact same storm, knowing that whichever community they warn most urgently will be the one that listens, and the one they warn less forcefully might end up paying the price for that uncertainty. This is the human reality quietly sitting behind every single strongest storm on Earth headline you'll ever read. Behind the satellite images and the pressure readings and the record books is a chain of real decisions made by real people, often with incomplete information, often under enormous pressure, and often with actual lives depending on getting it right. And this is exactly why the science of forecasting keeps advancing year after year, why satellites keep getting more sensitive, why supercomputers keep getting more powerful, why meteorologists keep refining their models with each passing storm season. Not for the sake of a more accurate headline, for the sake of giving those parents, those elderly residents, and those emergency officials just a little more time and just a little more certainty the next time a storm like this begins quietly forming somewhere over the open ocean. Because here's the truth scientists keep returning to again and again in interview after interview and paper after paper. We cannot stop the ocean from getting warmer in the short term. We cannot prevent a storm from reaching historic intensity once the right conditions align perfectly. What we can influence, entirely within our own control, is how seriously we take the warning, how quickly we act on it, and how genuinely prepared our communities are before the next one ever forms. That is the real message hiding quietly inside every conversation about the strongest storm on Earth. It's not a story about helplessness in the face of nature's power. It's a story about the narrow, critical window of choice we still have, even when the storm itself is completely and utterly out of our hands. One more thing before we close this out properly. If you've made it this far, you clearly care about understanding this the right way, not just skimming a dramatic headline and moving on. So do one last thing for me. Share this video with someone who actually lives somewhere storms can reach. A coastline, an island, a low-lying river delta. Anywhere the ocean can turn violent with frighteningly little warning. Not because sharing a video changes the weather, because the information sitting inside it might genuinely change what someone does the very next time a warning appears on their phone screen. So here's where we land. The ocean is warmer than it has been across the entire span of modern recorded history. Storms are reaching their most dangerous intensity faster than ever documented before. And somewhere out there right now, another system is quietly gathering. The exact ingredients it needs to become the next storm scientists point to when they say the words strongest on Earth. It will not ask anyone's permission. It will not wait patiently for anyone to be ready. But here's the part worth carrying with you long after this video ends. Every single time a community has faced down a storm of historic strength and walked away with their lives intact, it was never because the storm itself showed mercy. It's because someone, somewhere, took the warning seriously early enough for it to actually matter. The ocean writes the forecast, but people still decide what happens next. And that, more than any wind speed record or pressure reading ever could, is the story worth remembering the next time the sky quietly starts to change.